right now.
Yeah, I just turned on the recording because I forgot I turned it off.
So okay.
Sorry.
And I have 30 papers from different perspectives. I'm trying to interpret how to see where our things with the lattice would fit. It turns out that you saw it in the Stephen Dolan PhD.
ML sub.
Yeah, ML sub. That they use the lattice. So according to their interpretation, a type is a lattice. And right now I'm trying to just cut through that, but it's pretty deep. It's from the logic perspective. I've been reading from the magical incantations like second order unification, first order quantification, blah, blah, blah. What is the difference between ML type system and system F? It turns out the system F allows the universal quantification anywhere in the type definition, but ML.
What is the value you're hoping to gain by understanding this type of types?
I'm trying, of course, it to be clear by now, I'm building a compiler, a language of my own, and I want the type system as powerful as possible, but as quick type checkable as possible, because certain language from the years become much slower from the bigger programs. I want the type system at least powerful as, let's say, Scala, but to compile much faster. That is my long-term goal, but we'll see.
I'm somewhere left of that.
Yeah.
Want just enough power out of the ML side, and the lattice side gives me a very interesting amount of precision, and it's very cheap. So it's cheap and it's fast, but it lacks type variables. You can't type a map-like thing. So I need something out of ML or Hindley-Milner, something in that domain. But I don't want to go deep in there. And I keep hearing these scary terms like, hey, it's going to be undecidable because you got a dependent type. It's like, I don't think I have a dependent type. I don't want to be undecidable. Or have a decidability check that looks at the type and declares that it can solve the halting problem or not.
The dependent types, because the type depends on the value. Let's say you have a function that computes a type, and its type depends on the value you pass in. Let's say if it has to differentiate between 1 and 2. They can be type, they can be literal types. They are not dependent types yet, but if you pass 1 to this function, it will return a string. If you pass 2, it will return a Boolean. That is called dependent types, and it's one foot in the proving ground. Most of the type systems that have dependent types are diving into the program proofing and the program checking and proving, such as Agda, Coq, things like this. And the type system is pretty easy to become undecidable because it has to determine what you type you pass in. Right. If you cannot determine, it becomes undecidable because you have to solve the so-called halting program. Will the program terminate?
These languages you mentioned, though, they don't actually get used, right? They're kind of talked about in papers that people write at university, but nobody actually programs in them, do they?
Most of the programs, such as Coq, they have a pretty powerful type systems, such as other type systems become proven in Coq.
Right, they have
Scala.
a type system, but they don't have people using it.
Coq lives on because it's a theorem prover that is sort of widely used to determine that you've gotten like all the states. It's a state-based theorem prover. People use it to prove decidability, prove your device driver doesn't have a crash, that you have all the cases turned up in sort of hardcore deterministic code pieces. So it shows up in funny places. Not a widespread, but it has a definite solid user base.
Yeah. Coq for one, certainly, that is used as a theorem prover. I believe Agda is right half in the. It's still used as a general purpose programming language, but it has a theoretic capabilities of a theorem prover. And I believe I just last week I saw F* from Microsoft, which is headed in that direction. And they have a theorem prover called Lean that has the capabilities of Coq. So I believe we are slowly but going in that direction.
So like functional programming languages are like 10% of all possible, 90% of people use imperative, object-oriented, whatever. 10% people do functional languages, of which most of them do something with Hindley-Milner with maybe 1 or 2 minor extensions. And then there's another 10-fold drop-off or whatever to the next most common. With things like Coq are probably another 100-fold drop-off. But the user base is probably in the thousands. It's a theoretically useful, I mean, it does a useful job that people still want to be done.
Yeah. It's academic at best.
Yes, yes, but it's
much of the type systems are proved in Coq for various reasons. Yeah.
Right. I had a guy, I want to say use Coq on a non-blocking hash map to prove that I had all the state space covered.
Yeah. That they use for I believe the F-star programming language goes in that direction. If you write the function below it, you write what constraints you need to satisfy, and the theorem prover checks your specification, so-called.
Yeah.
To write more correct programs. Yeah. Their value, I believe, will become they will become more valuable when the programs become huge, like hundreds of thousands of methods that needs to be checked. It will be their sweet spot.
Right. So it's not a daily compiler kind of thing. It's every now and then. Yeah.
And I try to experiment with type system that tries to compile as fast as possible and be as powerful as possible. And we dive into the weeds if you want to ML style, or that's if it's rank 2 polymorphism, that means like the option type. Will the type that accept types as a type will be type constructors. That's till the type system becomes decidable at rank 2. That is the highest rank it can get. Above rank 2, the type system becomes undecidable. So it has to maintain. That's why Haskell has a specific flag called runtime types to make you aware that your program cannot terminate with quote unquote.
Not the program, the typing won't terminate.
Yeah, the typing.
Yeah, the usual place where people get themselves into trouble is if the types are both self-referential and have negation. If I can say my type A is all of the legal values that are not in type A, now I have a problem.
I've been thinking about we may be missing something because we treat the types as a set of values, but the type is not only a set of values. It can be a set of functions. A class is also a type. It's not only a value, but it has a functions, and so we have to think about this.
I'm running in a different direction.
In your AA lattice, if I say A equals the dual of A, how is that going to interpret that?
How's what going to interpret that?
If I'm defining something and I'm like, I'm making a new A, and then I use the colon and I try to type it as dual of A.
No, well, I'm not letting you type it as a dual, but I would just take it as a dual. And the duals, if you had one as a primary type in your language, I would have to validate that what you gave me in the end was something was A or higher, a dual of A or higher, which is basically an uninitialized or uninitializable, unusable value. It would not be an exciting program. I could type it, it would just not be exciting. You can't use
So it sort of types as does not compile.
Yeah, basically, not usable. You could type it as long as you didn't do anything with it. Right.
I believe we should treat the dual types more of an implementation detail because
could you explain what a dual type is?
Oh.
Yeah, I went round and round with these other guys. So this is the lattice. My lattice is symmetric. The duals are everything above the symmetry line. and everything else, what you normally consider types to be below the symmetry line. So there's two uses I get out of symmetry. One is the join operator, which would have like a cast as a join. It runs you the other direction in the lattice. So a join operator is done by dual, dual, meet, dual. So my lattice is defined with dual and meet. Now the dual is typically a bit flip. So dual is super cheap. So I get a complete lattice that has a meet and a join at the cost of implementing only a meet and a bit flipping dual bit. So
yeah, you are clever. You are clever to interpret the types as the 0 is the center line. I show it. If you flip the bit, it becomes the negative type. That was cool. Yeah.
Well, I worked a long time to make sure that fit in the lattice and was still a lattice. Got all the right lattice properties and that.
Cool.
And mostly it was stupid when I got the answer, but it took me forever to get the answer. Cool. The other thing that the dual types hold on to or understand is they understand ambiguity in a precise way. So they can stall a decision indefinitely while they hold on to, you might be an int, or you might be a float, or you might be a bool, and I don't know yet, and I don't care. I'm just going to hang on to the concept of you're one of these, I'm not sure what yet, until I get more facts, and then you drop in the lattice, you lose one of your choices, and you get a more precise answer. So it lets me hold on to ambiguity sort of indefinitely. That also turns into, like, I think at the moment at least, it looks like it turns into interesting to good error messages where you have a conflict and I come along and I can say, well, so far you're both of this and of that, and you can't be both, but I'm going to be ambiguous and say you're one or the other and I'll find out later. And eventually I had to find out that I don't find out. Now I have an error, but I can tell you precisely, you tried to be this and you tried to be that, and you tried to be this other thing, and you didn't make it clear which one. So here's your error message describing what set of things you were trying to do that were not in conflict, were conflicting when all taken together. So it's a way to hold on to ambiguity indefinitely. It's a cheap way to describe a lattice that is complete and has a meet and a join. If I look at
so in short, I believe it will have sharpen the types. It's not too much of a big deal, because we at the other meetings we delve pretty deep. I don't believe we should. We can treat it as a more of an implementation detail, because the join is implemented as a dual. Or it has to be. It has a different machinery if you don't use dual types. It has more complicated.
Right. You end up duplicating a shit ton of code to do a join.
Part of the reason for your choice to use this was because you're trying not to have to declare the type of something. You're supposed to infer it.
Right. So that's a different one. That is, I want to do type inference so that you can optionally type as you go and skip the types.
Isn't that one of the reasons for using the lattice, though, specifically?
Yes.
Yeah.
The lattice is an experiment, right? So the observation was from Hotspot, I was given raw bytecodes, and using a lattice alone, because it's fast and it's cheap, I routinely recovered all the smart type information that the Java had when it threw away when it made bytecodes. So then
I just designed a language that didn't throw it away.
So then my question was, can I just use forward flow data flow typing to type? And the answer was I can get close, but I missed some key things. So then I went back and said, I want to go pick up the key things. But along the way, I was still doing, the forward flow typing, because I have that infrastructure all in place and functioning, working well. The notion of dual or not the dual is an implementation strategy I did umpteen years ago for Hotspot in C2, and it worked out well then. So I just.
I would add that the way Cliff implemented the type system with the duals and the type lattice become much easier to type functions, to type programs faster. It's such structured in such a way that the typing becomes more faster. In some cases, I believe orders of magnitude faster.
It's really cheap.
Yeah.
The typical construct type based on what I see for your inputs turns into, microseconds at sort of numbers.
We'll see adding free type variables, declaring the types, how can be fit in this system.
And that's the Hindley-Milner game that I'm sort of mid-progress on. I'm currently basically running Hindley-Milner and then using it to lift types in the lattice. And I don't have evidence of an interaction usefully done yet. In the back of my head, I have my old thesis work, which did look for value equivalence across program states with an n-squared algorithm that I beat down to n log n. And Hindley-Milner looks for type equivalence between program points. And I keep thinking there's some way to go, loosen what I did for value equivalence to claim it's all type equivalence. And it's not quite the same thing. So I don't know that those are, but the back of my head says there's a way to go do this, in which case I would get a useful interaction between values and Hindley-Milner typing that would turn into something better down the road.
I have a paper that they influence CPROP and closed hierarchy analysis, that they have some symbiosis, that they get get both. Yeah, when you use both of them, you get more value than using them separate. Yeah.
Throw the link into the chat, because that's
okay. I will find. It's a short paper. Yeah. I will find it and send it. Okay.
So, you had mentioned that you had realized in your quest that types were more than just values.
The main problem becomes how to interpret them, how to structure a framework around them to interpret what is a type. And most of the type system, a type can be a set. It's how interpreted. Yeah.
I have this funny zone where the below the center line, the non-duals are typically sets of values, like you'd kind of expect. When you go above the center line, how do you interpret it? And my interpretation is, it is the join or the choice instead of the and or the must take all. It's the choice. So below the center line, the sets of values are all things that you must support in the code. Above the center line, the sets of values are all the things that you may choose from. And
how do you represent those types, though? Are they just a number or a pointer to a thing in the lattice, or is it actually a set for each type?
Everyone is some sort of set representation. If I flip the dual bit, I flip the interpretation from take them all to take one of them. But that's
so is that represented as like a list of pointers to the type definition, or?
Oh, okay. No. Now you get into like the hardcore low-level type representation. So I have basic types and I have structural types which build on the base type. So like a base type, an integer. So if those have an integer, I have a couple bits in there that tells me it's a int 1, 2, 4, 8, 16, 32. I have a bit that says it's high or low. I have another bit that says it's actually a constant, and then I have a full 64-bit constant in there. So I have this as a structural thing in the implementation. I hash cons it, so there's only one of them, and they're unique, and I can compare them with pointer equivalents. Now, suppose I have a float, has the same thing, but it's different than an int. Then I have a structure or a tuple, and a structure has a collection of these and a bit that says it's high or low. And a structure can have field names, and the field names are also highs and lows because a tuple is a structure with no field names. And so you build up recursively, you build up more complicated types. With a structure that is an object type, which can live in memory. So memory is a collection of object types. So still building 3 tiers. There's a memory, it has within it some structures. A structure has in it a field.
So if I want to represent a type, is it a bit vector that points to all of the primitive types and then all of the ones in the that have been user defined?
When you say you want to represent a type, what you typically have is a C++ pointer, a Java pointer to some structure. Now, what kind of type do you want dictates what kind of structure you're looking at.
It sounds like your type, you and Theodore are both kind of approached it, and I get it, Cliff, for you, because you're thinking of everything. You always start from assembly, right? So it's like, okay, DB, DW, I'm going to build everything from there, right? Like,
Well, it sounds like he's starting less from assembly than from sea of nodes.
The types are not sea of nodes, but they're close.
They're structs of structs.
Yeah.
Right, you think of everything in terms of its structure, I think, which sounded like what Tito was saying.
There's an implementation, there's a theoretical notion. So the theoretical notion is sets of values. Now, how do you represent sets of values? Possibly infinite sets of values. Well, obviously you do all kinds of approximation games, and you have an int which represents all of the ints and that.
For me, it's like such a foreign concept, though, that you would think of it as sets of values. So I'm sure it's.
Okay.
So Cameron, what would you use instead?
I would think of types as what they do, not the values that they are.
What do you think about algebraic structures then? Because I think that marries both. So
I could probably answer your question if I knew anything about type systems or computer science.
Algebraic no. I'm just thinking high school algebraic structure like a ring or a field. So you have the set, like integers or real numbers, and the operations that you can perform of the values of that set, like addition or multiplication. So it's not just the reals themselves that would be the type, but the reals and addition operator defined on reals and multiplication operator defined on reals. If you pack those three concepts together, then you have an algebraic structure.
I would rather omit everything other than the operations themselves. Like, why do you need anything else? If you can't define it in terms of its operations, you can't define it.
Well, the operations themselves need to have a domain and codomain. So you need to still define the inputs
in assembly, yes,
and
but not in programming. I mean, sandcastles of air, right? Like even construction is an operation. Even state manipulation is an operation. Like I like what Cliff did, but only because he boiled it down in one leg of the tree, which is the kind of structural form, and I boiled it down in the other way, which is the operational form.
I would take both.
But I like the structures. I feel like if you show me your flowcharts, I will be confounded. If you show me your tables, I won't need to see your flowcharts. I think I'm misquoting that.
The main problem lies in how you represent the types, because this will allow how to make computation in it. You represent the types as a set because you have a set theoretic operation. One point I can add that we are thinking here as a homogeneous type, but that need not to be the case. In type theory is a set of objects. What is an object? Anything can be an object. And operations between these sets is determined what is a type. If you add the type variables, then it becomes more complicated because you're trying to guess what the type should be. And you introduce a type variables to narrow down what the type can be. And you use further operation between these type variables in order to tighten the constraints of what type can be, because you don't have a type annotations in languages such as ML. And you represent these things in some structure to be able to make some operations in them. In most type systems, the types are set, but in homotopy type theory, the type is looked at as a more, how should I say, from outside in. If you look at individual elements, you're looking for the types from the inside out, as bits of elements you move around, you use union, intersection, and in order to determine the type. The homotopy type theory is more for theoretic perspective, more elegant, because you don't talk the values themselves, but such imaginary operations, because I'm not at least on the bottom of it. Bob Harper has a pretty cool lectures on homotopy type theory.
I'll be doing some reading for sure.
Yeah. It has lectures on YouTube. I will throw the links.
You can throw some more links in the chat if you got where you think somebody's got a good explanation. That's fine. Yeah. So I'm doing sets of values because that was the typings I grew up with, and operators on those sets for the primitives. Yeah, no, that's still the case. And then you build up functions on more complicated functions for complicated structures.
If I want to add a property that's like, this thing better have scope that does not survive the function it was called in so that I can put it on stack and it never escapes. Is that a reasonable thing to have live in the type system, or?
Well, it's certainly something I'm currently tracking in the lattice. That is a thing I have in my lattice right now.
Is if this thing ever escapes, that's a error, don't compile.
Well, I'm tracking if it escapes or not. So I don't have an error version. I just know that it escapes or did not. I'm using that because I have closures as first-class citizens. They're not exposed to the user per se, but they're first-class citizens. So I can have side effects in closures and have generators and coroutines and all the shit that you get out of full-formed closures. But I want to know if the closure escapes or not. Because if it doesn't escape, I get to do one set of things to it. And if it does, I do something else. So I'm tracking it in the typing system because it sort of came out for free.
Do you have any way to get that information back to the developer?
Yeah, I could. Yeah. I could throw it in as a bit on a type that said, and if this ever escapes, it's an error. That would be a case of the type says the value of the type includes it escapes or not. And the user adds an annotation that says it better not, and therefore you get a type error. Now, what does escape mean in this context? What it really means for me is I have a set of aliases. This is, Cameron's take on Cliff doing only assembly. Every new type thing that was ever defined is a constructor which has its own unique alias, and I have a set of them. That is a bit vector set. And then I track the bit that says they escaped some context. And I know layer by layer by layer in the call hierarchy what escaped and what did not in a conservative way, conservative approximation. So you can have something that doesn't escape, but I can't tell it. I can't prove it cannot. But I get to prove lots of things, especially in all the sort of easy trivial cases that they just prove straight out. So I would think the 99% case where you want to know that this code that I just wrote does not escape the entire closure stack behind. Like Scala, I know has this problem that occasionally he escapes the entire closure stack, and that users complained about mysterious slowdown. So they did something.
If you capture the this pointer, if you capture the this pointer,
yes, yes, then you blow out, yes. And so I can detect that directly and allow a user type that says you captured the this pointer. This is not what you wanted. Unless you asked for it specifically, you really didn't mean to capture the this pointer.
Well, I end up with two things in my head. The first is I like the idea of being able to put an assertion in my code that says, this thing never escapes. If it escapes, that's an error, let me know.
It's a typing system.
This is not
a runtime assertion. This would be a type error at compile time.
And the second one that would be useful to me is like, I kind of want to have an IDE that colors things that are local different than things that escape.
Yeah, that's a.
So it just becomes very visceral of, oh, I changed this one piece of code and suddenly half my variables just escaped.
Yeah, right. So that's a language server for which you need a typing system out of the compiler for which I claim I have. I don't have a language server, but I could give those types out. I incrementally compile the whole program character by character in a cheap way by being incremental. So I certainly could, plow in.
That does sound very useful for a language server.
I'm sorry?
That does sound very useful for a language server.
Yeah, exactly. Yeah. That was, some thinking was going around there. So not my current state of implementation. Feel free to pile in and help.
I would say the type system is such a picky topic because anyway, it has so much interpretations because it's not narrowed down what it exactly should be. It has a different interpretations. And that becomes a little tricky, and in order what you believe
goes to what people think and what they mean.
So
if you're talking about what a person means, then
it's the building block. Like you can't describe anything without understanding that concept.
Right.
Yeah.
And
it's the alphabet.
How you think about building changes according to what you think types look like. So this is the problem that Tina and I have been having with the academic talks we've been going through. They have a very different notion of what a type is, and therefore the kinds of things that you can build out of a type and how you think about programming. So it's been very entertaining.
it's a little pretty complicated how you represent the type, because that dictates how you will compute a type essentially.
Yeah, and what you can represent with it, and then how you think about it, and how you, and then they come up with these little toy languages that work really quick and easy, and claim you can type all kinds of stuff. But
if you type some function X and colon and type A, how to gain knowledge about that A, what it represents, what values can it represent, how to be compute, will be dependent or not, and such as.
We just got a paper this morning from Jan where they're talking about people did structural typing in Ruby and discovered that the users hated the error messages. And so there's a pile of heuristics that follow the structural typing that narrow the types in a valid sound way, but they don't tell you everything you can do here, but they instead tell you things that sound more reasonable. So
and essentially, if you take away the type variables, so you, like ML, don't ascribe types, the situation becomes more complicated, because the compiler, the typer, need to figure out what the types can be or should be. And
yeah, I think it's actually really more complicated. I think once you have the typing system in place, you then the paper that Yanta makes total sense to me. You run a heuristic that says, hey, it has 2 uppercase. How many types in the world have 2 uppercase? Only string. Therefore,
that would be true for the monomorphic types and for the type constructors such as lists and options. But when you go higher and you don't tell what the type are, then it becomes arguably more complex for the type
maybe I don't want to go higher then.
yeah.
But that assumes that you live in a world where you can know all of the attributes ahead of time. Like if I'm in Python where I can call an attribute on an object and it's like, oh, this doesn't exist, I'm going to call getAttr, hand you a string, and you can do arbitrary logic based on that.
Yeah. You need to the Python do not know the type. It knows that only at runtime. Just call this function. If it doesn't have this property, well,
you get JavaScript has that thing. How many times have you seen whatever none is not a function? That's a very helpful message. Not. So some amount of pre-declaring and pre-understanding is what static ahead of time typing is about.
The more of the type systems will always be pushing the less type annotations, but you need to some way to tell if you have an interface. If you leave it without the types, then that interface, the functions become interpretable. They can be different types. So you need to ascribe them in order to conform this interface, in order to rely on the fact that this function has these types. Right? If not, they better not change all of a sudden and have a different types. That's if you leave type annotations, the more if you restructure the code, the compiler can figure out. But you need to some base ground in order to rely on your types in your program. So to not break certainly.
I guess I'm in the mode of it. It's there to prevent you from runtime errors, late binding runtime errors.
Yeah.
Binding points.
Yes. Let's take for example. Someone has a question. Or not?
And not just errors in the sense of throwables, errors in the sense of this just got 10x slower.
Yeah.
That's a separate set of errors that I'm also interested in. By claiming that some things are known to be performance sensitive or can go slow. That's the whole I escaped at this point, or I whatever. And I want to have those as a thing that you can annotate. It says blowout if the following things happen. Like you can use auto boxing of primitives. Well, there are times when I don't care and times when I do. And then there are times when it's obvious and times when it secretly happens because it's auto boxing. And I want to block out those times where I care and it was happening secretly. And that's, for me, that's a type annotation.
Once you make the types more powerful, then more things become known to the typer, and hence the compiler, it can better optimize the code. For the stronger types, it can make better assumptions.
Yeah, there's a difference thing that says like runs faster. I'm looking for expressive without a
Yeah.
lot of annotations.
Yeah.
I'm writing all this
That's-
code in Java now, and so it just spews annotations out everywhere.
Yeah.
Ludicrous. And we all know, okay, Java's the gold standard 25 years ago. Now everyone, if you can't beat Java, you ain't. So you have to beat that. I'm all ready for, less annotations. Now, how much less?
I'm for less. Yeah, that's the main question. I'm for less annotations too, but you have to have annotations.
So when you say
Nearer to the line.
annotations, you mean type declarations?
Yeah, type
Type declarations, type descriptions. Yeah.
Somewhere in the code, I say, if X is an instance of foo, then I cast X to a foo and I do some operation and I store it as a foo in a local variable that's typed as a foo. And I wrote the word foo like 3 and 4 times. And somewhere in the world, I want to say, since I did an instance of foo, I don't need to write foo ever again after that if test. It's a foo. So that's what I mean by your death by annotations. There are also plenty of times when I say, I need a temporary variable and some complicated if test on one of the arms and not the other. So ahead of the if, I just say int x and int x and int this and int. And it's just a stupid one-line lifetime thing. And I don't care. Why do I have to say int? I have a for loop over an array. And because I'm using 2 different arrays or I'm storing into an array, I can't use Java's syntax for a fast, whatever, cheaper syntax for arrays. I have to do for int I equals. Okay. This is just an index variable. Why do I need to say word int? It's very obvious from context that it's just a dumbass integer from 0 to the max of the array. So that's another annotation, I want to get rid of.
So guys, what are your sentiments about type annotations? Should they be present or should they be absent or somewhere in the middle?
I want them to be present because I want to use them as compile time assertions.
Yes, they have to be available to you, but you don't need them or you don't want them everywhere. That's the difference.
Yeah, you have the right to.
I kind of like the general way they came out in Java, which is, they're required, but we'll support val or whatever it is now.
Yeah,
like,
val's a step in that direction. Yeah. I haven't decided I want to jump my code base to whatever JDK 11 or 16 or whatever it is.
It's an interesting. It's an interesting comment because in your earlier comment, you said I have to say instance of, and then I have to cast, and I think in general there's kind of a hidden thing that you weren't saying, but it's kind of implicit by this. It's not so much that you hate saying it's an int. It's that you hate the fact to get that behavior that you're describing, that you have to test it at runtime, and then you have to cast it at runtime, and then it's like there's a combination of what happens at runtime and compile time, but there's also the repetitiveness of it, and those are like two different aspects.
I know I have to have a test because exactly this code is choosing amongst a set of choices. And the instance of is picking one of the choices. It's a guard or a filter. Now, having made that guard, I don't want to be repeating myself afterwards. The for int one, for int I equals 0 to n, is a different one altogether. That's just a common use case where I'm marching through a collection and the indicator that I'm in the collection is some integer value. And that one's just a dime a dozen. And I claim it was, we should stupidly have a slightly different syntax to drop that one. That one's actually less painful though. It's the one that's painful is I don't have foo, I have long, complicated type names. You would love them, Cameron. Okay, they're not that long, but they're longer than what I want to type 3 and 4 times.
Yeah, I was just doing some searches. I think one of the interesting side effect, because we hate casts with a passion. It's one of the things that always drives me nuts working in Java is how much I have to cast.
I have a ton of them. Yeah.
And it's always a 2x because I first have to test instance of, and then I have to cast.
Yeah.
And we have almost.
So what do you want? You just want instant of to narrow the variable for everything.
Oh, we do, but that's not the. That's kind of that's cute. We do that, but it's not that stellar. I think I think the more amazing thing is, what are the options for getting rid of the test itself? Like why are casts so
So I use
common?
some kind of class 3 times in that example. And if I use Y a few more times, I have to have at least 3 references to some kind of class. So sorry, yeah. Now, how do you get rid of the test? Carry on.
Once you go declarative, it becomes increasingly mandatory to coordinate that thing that you wrote in your functions. So you have to keep referring them. If it's absent, it becomes much easier.
So I have a question here then. Like, why do you keep using instance of before you cast? Why not just cast?
We have to have a test.
Why?
Because it could be not an instance of some kind of class.
So what? Then you throw a class cast exception.
No. I have things that I want to do something else with. If you're one of these things, do something else, do something else.
Okay, well then that seems
Right. You could write that if using the if structure of try catch, or you can write that if using the if structure of instance of. But
I don't want to go to try catch as a way to write an if test. That seems.
So I'm going to argue if you have an if statement in this whole case, then what you're missing something in the design, because to me that seems like that's a perfect use case for a double dispatch.
Right, and then I get to the problem of the executable code, the y dot stuff is far removed from where it's being used. So if everything that I say instance of instead becomes a virtual call, so I say x dot do stuff, and it's always empty for everybody else except some kind of class for which it does something exciting, then
you're just getting into, like, even if you're using an interface in that case, like that should roll up into some form of localized call, like it be a bimorphic or monomorphic optimization.
It's not the performance question, it's the code for y.stuff wants to be where it is, not inside an interface call or a virtual call on some kind of class.
Why?
Because it's in the context of the local context. It only makes sense in the local context to do something here.
Yeah, I have to agree with Kirk here. I think that some kind of class, there's something special about it, but that's a notion that belongs at a higher level in the hierarchy, so that you can ask that more general class, are you something that I can do stuff to?
The problem here is that the examples are too small. I'm going to repeat this code. I do repeat this kind of style of code 1,000 times on 100 classes.
So yeah, so and that's the issue, right? If you find the missing design element, all of a sudden, typically what I see is you see an implosion in code because that missing design element allows you to get rid of the if.
Please come write a compiler for me.
So like you like
I've been doing this for a very long time. I've never seen a tighter, better way to do this. Please come show me how to do this by writing a compiler.
Yeah, okay. Well,
I mean, but seriously, pile into the code base and come up with a suggestion that has clearly more readable and shrinks the code. I'll take it every time.
So you're talking about in your AA code base?
Yeah, but not just AA. Everywhere I write code, I have this problem where that I've already minimized all the other stuff that makes sense to minimize. What's the difference between some kind of class and other things that X could be is the key differences. However, there are many of them and they are scattered throughout, and where they behave differently, I want to have the code that describes the difference in that context, not buried in the class for some kind of class. They need to be in the code that's doing something here.
Well, but that's the purpose of having class, is that the class behaves with appropriately.
Yeah, but it's an n by n problem, and you're only talking about the n. Cliff is saying that there's an n. Yes, he likes solving that, but he also wants to solve the m because
Thank you.
n by n.
Can you give a use case? Is this something like you have expression tree watching and you have different classes representing different things in the expression trees, and then you test if it's this or is it that or is it that?
Right, close. So in the case of many of expression tree walking things, there is some common things, which I have done the breakout just as you guys are asking for. But there's a whole lot of one-offs that just this guy does here. And nobody else does it, and nobody else does it anywhere else.
I agree with you that that should not be done in the class hierarchies, and I absolutely don't agree that this should be done in interface that builds the class hierarchy somewhere else. It has to be localized, and I think the best solution for that is some kind of pattern matching
Well,
right now.
it's also goes kind of back to one of the main
Yeah,
like
pattern matching.
universal things that
I think that's pattern matching. Yeah, I think that's
pattern
the
matching in Java. Yeah.
it could be, but it is something that seems to tie most language people together, which is there should be kind of like one best place for everything, right?
Yeah.
And that's basically what we're talking about is how do you find that one best place when you don't want it buried in the class? You want it in the use site is basically
Yeah,
what
one
we're
of the
saying.
use site in this
And,
case.
and a type match could be that, you know, some languages have a match construct where they say
Right.
match.
And I don't know what Java currently does. Switch does something maybe.
They're hacking something into Switch.
They are considering to make a structural matching on the switch.
The problem is with the one off, the if makes sense. If I have a two off, a class, and if I have more than three, I should virtual call it and throw it back in the other guy here. I'm making up some syntax here.
Okay, I don't know.
Like this is a switch that I just totally invented syntax on, where if you're some kind of class, I do something, and if I have 2 or 3 elements in the switch, that sounds great. If I have somewhere between 3 and more, I would break it out and say.
We do this all the time. You know,
something like
but
this.
it's handy for things like serialization, where you want to peel off 100 different known cases. You know, I want to handle int 8 versus int 16 versus int. You know, it's like serialization is not supposed to be beautiful when you write the code, right? But you
And
do want to yank
sometimes
it. Go ahead. Sorry.
I was going to say sometimes the thing that makes sense is to essentially do both. Here's my print function. It handles if it's an int, it handles if it's a string, it handles if it's a float, and also it handles if it is a class that happens to have a toString on it, in which case I will just call toString and then treat it like a string. And now I've
That's
split
for
it.
the
I've
reading
handled some
case.
of the cases in line, and I've let classes handle the cases themselves if they're being
Yeah,
special.
I think York actually gave that example in some of the work he did a few months ago, right? Does this ring a bell, York? You were working on toString. I can see your code in there.
Yeah.
So yeah,
Well,
accidentally locked
you
my
don't need
screen
an
there.
if statement to handle that print statement case. You just make the appropriate call. You know, method overloading should manage that. I don't, you know.
Right. So that's
There's a way to go about that.
My guide here is like, how many if statements are you actually using, or switch statements are you actually using in the code? Because and then when you start looking at it, what an if statement is actually doing, because conceptually, it's rebuilding context or rebuilding something that you knew once that you've lost.
Yeah.
Yep.
So
And so the question is, why did you lose that?
because I
guys I
don't
worked
have
with used to say I can replace every if statement with another level of inheritance.
another level of what?
It's not necessarily inheritance.
Inheritance.
Oh,
I mean,
no.
he was making a bad joke.
So
Context.
Yeah.
Kirk, in this case, what I have is a graph IR. There are pointers from nodes to nodes. The
Mhm.
pointers are all of a generic node base class, but I
Sure.
have a bushy class hierarchy of 50 odd classes.
Sure.
I don't know, I know from certain node types, I know what some of the pointers out would be. Oh, the pointers are all put in an array of node pointers to their def sites,
Sure.
which is typed as a base node class for the array. So I pull an element out of the array, and I know it's a node, but I don't know what kind of node it is. For certain node classes, I know what those pointer things are, what classes they have to be in that array, but I have no way to express that type in Java.
Okay.
So I've lost it because the you know, if I have a call function, node slot 0 points to some member of the class of control nodes, and slot 1 points to some member of the class of guys who produce memory output, and slot 2 points to some member of guys who produce a standard argument for your display pointer, and 3, 4, 5, and n are your normal argument pointers, which are typically limited to nodes that produce scalar values. There's a function pointer input as well. And these are all stored in an array. So all the generic tree walkers can do for I equals size of array, walk the array, and that's how I walk trees or graphs or whatever I'm walking.
Yeah,
So
sure.
they are typed as basic nodes, but I know something about the type at the time that I built it. Later on, when I'm in the call guy and I'm doing his generic value, compute a new value, he will know that he has to have the following types on the inputs, but he can't express it in Java. So I have to do a cast. Sometimes I have choices among things and I actually don't do a bare cast. Sometimes I do a bare cast because I know, and I can't express it to the compiler, and the compiler puts a runtime test, which will blow, but it never blows in practice because I know, but I can't express it. So does that start to make sense here?
I mean, I know exactly what you're doing. I'm just seeing, you know, to me, it just seems there's still a design element missing here that would help you resolve this thing, because to me, it feels like this is a case for, you know, I'm going to dispatch in, dispatch back.
Well, I'm all happy. Like I said, I'm all happy to go back and forth as to what is a better design paradigm. But you know, part of it is also I am going to demand performance in the end. So if it turns into something I can't get thrown away at compile time, I'm going to be unhappy. I don't know what a GAT is. What is this? Is Matt.
So generalized algebraic data type. So it sounded like it may solve this problem that you had to cast, because at some point you lost the type information, even though you knew that you were in the branch. That could have only been true if you had a particular type, right? You're dispatching you on your expression tree, and you know that if you dispatch to a particular case, you are in a particular situation that can only be true for one type, right? But you are losing this information that you have to cast.
Yeah, it's a loss.
Yeah, I was.
So gadgets are like, they are exactly like ADTs, but they hold on to type information in one sentence.
There's two ways you
they
can
solve the
approach.
cast problems, I would say.
One is the approach during like a match, that you mean you want to at runtime this to happen, and if you say it's this and this and this and this. The other way is
and one where I have to do an if test, because there are a couple of choices here.
The other way is, like we said earlier, you have specified more information in the types, and how you compose them. The GADT would allow you to match on the expression, because you have a fixed structure beforehand, and you have maybe type variables that allow you to more fine grain to generalize some of the structure, but you know it has to be some of this type. And the GADT just allow you to let's say add more type variables into the mix, and that builds out to more precision in the types, because you can have.
It's like pattern matching that remembers which branch you were in.
Yeah. So there's not a case where I have pattern matching, lose it, have some code, and pattern match again. I mean, that happens, but that one's really rare. It's more the case of I have an overall function that does something complicated. It's called internally inside of much more complicated code, doing like the entire global value numbering computation with virtual calls in every different direction. And then in this code, at some point, I want to say, I happen to know, I've had two cases. One of them is I happen to know that your input on array element number 0 has to be a control-based node, and I've just got to cast it. And that's an invariant that I don't know how to describe, because it says for.
I really think it may be similar, but if you have time, compare this in this article. It could be that you are in the same situation that the I int is in this expression tree that they have. So just you have a conditional, and you don't have to cast. I think that's analogous exactly to the situation that they have an integer node, and they don't have to pass it to other type.
I'd have to go look up what they're doing exactly. I've stared at these things in the past, and I remembered they would be, if Java had them, this covers some of my cases, but it doesn't cover all of them, and I don't know what does. And the other one is I just have some runtime things for which I have just a one-off. In this particular context, I know right here and right now, if I see a foo object, then I can do something fun. So I'm going to do an if test on a foo and then carry on from there. And because it's the in by n, I like to how you express it. It's the in by n problem When one of them is just a 1, or they're both of them just a 1, I want it at the local site. And if I have a lot of them everywhere, I'm going to put it in a virtual call. And what's the other one? If it's used everywhere, then I want to have some cheap expression. I have to think about the big M. We don't have to carry the infinite runtime for all objects. Okay, yes. Yes, there are times. Well, this is a Java versus AA. In the land of AA, I don't know yet what I'm going to have to carry at runtime, but I know I can carry a lot of information already from the typing system, and I won't have to have that at the. In particular, I do not want primitives to carry any runtime information.
Let's say if you have a JDT that would allow to not cast the type, you know the type from the structure you infer beforehand. That's essentially what JDT means. You won't have to cast the type because the type system can figure out what this specific case what type should have.
Well, I was actually meaning more from a structural point of view. They're kind of heavyweight objects and not heavyweight objects for some definition of each, because you generally have a type of something and its structure, and each of those is sometimes optional. So with an int, for example, you'd like to have the value because that's kind of what the int is, but you don't want to carry around the fact that, hey, I'm an int. Okay, we'll throw that part away if it's always an int, right? But then sometimes you can actually throw the other one away, because sometimes the type itself tells you what the value is.
Oh, so, like nil as a type?
Like nil as a type, or like enum, or, so theoretically type and value end up being synonymous, so you get a choice.
Well, I certainly have types of size 1 value, and then whether or not that one turns into a code carrying runtime. No, in runtime, it'd be compiler would just take it as a value and optimize it as a constant. Wouldn't necessarily be carried anywhere. No need to.
One interesting thing with the JDTs, I don't know, with match type, you have to know what the type cast should be, the type test when you cast them. But with JDTs, you can, I believe, you can fix constraints, because at some node of the JDT, it has some type T, but has to conform to int, let's say. It has to conform to some properties. I don't believe that the match type can express this. Or I don't.
Yeah, no, match type. Well, no, okay. Match type gives me a basic type. Could be a complicated type, like my some kind of class, which in turn has all the properties I want on it.
But the JDT would give you the ability to talk about abstract types with certain properties. That some of the nodes, it has a class of T. That T has some properties that JDT would allow to talk about these properties. Instead of a match, you have to know exactly what the type should conform to. You have to know the type beforehand. It's something I believe when you do a match, you have to say that you have this set of functions. Let's say it have to have a get method and a set method. That's
all right.
That's I believe that's more or less yes.
I will stare. I think it won't help me in the land of Java though, without doing a rewrite into some other language. I'm pondering some future rewrite into AA to be self-hosting, but not necessarily into some other language.
Yeah, so did someone play with Scala 3? It was out a week ago. Did someone had the chance to see what its new capabilities, some impression of it, maybe? Or
what's new in it?
Yeah, there are lots of interesting stuff, I believe. I haven't tried yet to see because mainly I'm drowning in papers.
Yeah, okay, fine. Well, I just whipped up the new in Scala 3 webpage, so shiny new syntax. New control syntax. Oh, goodness.
The interesting points from you would be AND or OR types, union types and What
Oh,
was
no,
the-
syntax is always interesting because I'm the big, no syntax type.
Yeah. Mhm.
Yeah, okay, so they're just dropping parentheses. Ooh, I don't, it looks like Python. I don't know. what-
Yeah. I'm have mixed feelings about it.
I like my curlies. I just
They have a
don't need to keep,
union and intersection type in the core of the language.
that'll be a
which-
change.
yeah, that is a pretty powerful change.
Yeah,
Yeah,
explicit nulls. Oh, Cameron.
yeah.
Yeah, and there's null in the type hierarchy. Da-na-na.
So I have a
So,
syntax question that I'd like to poll the audience on.
Oh,
If you have a closure, should you have default argument names such that I can just be like, oh, _1, _2, _3, and now I don't have to set variables at the beginning and be like, hey, this is a 3-variable function. It'll just look at it and be like, there are 3 underscore numbered things here. Those are my default variable names.
give me an example of some syntax that doesn't have this, and then what you would do different here. Because you said closure, which has a specific. Yeah, right.
In your closures, you give a list of variables and then an arrow and then a block of code.
Yeah, that's what I'm doing. Yes. Exactly.
If I say, hey, the special symbols of underscore and then a number, those are the arguments to the function.
Okay, so that would be.
So I would just say _1 times _2 and end the bracket rather than having to pick variable names.
I would claim I would want some other syntax to distinguish it, not unambiguously distinguish it from somebody who intends to call this way. Something, and I'm just making up another syntax here. It says the ... means I pass some arguments and I'm not going to bother name them. I'm just going to go under 1, under 2.
Yeah, I would just pass underscore there and be like,
But
I'm just using the
underscore.
underscore.
Yeah, an underscore would be a good one.
Aaron,
It becomes tricky.
What's the benefit?
Yeah, that's my question. What's the benefit between a
What are
one
you trying to
letter?
accomplish?
I think the benefit is similar to some of the benefits I've seen in awk, where you just know what the columns are in awk, and it makes it easier to write one-liners in your language, if not being particularly helpful for large applications.
Awk doesn't have scoping to complicate things. You have a function that has 3 arguments and nested one which has 2, and you refer to the third one thinking you're getting this argument, but you're getting that one, and no.
Yeah, I could get over
Very
that.
hard to read.
I have a question. Do you know the closure how many how many variables will we accept working with beforehand? A static assertion.
I do.
Yeah, because
And I can allow variables, but that's
if you do ... that means any name of arguments with any names of variables, and just have to
no the
see what I'm using.
The ... was me saying it has to be under 1, under 2. I was just throwing that sentence out there.
Yeah.
And Aaron said, no, use underscore, which, yeah, totally. Okay, just use underscore. It makes more sense.
Okay. I believe that someone said it, that is the Burgeon index, because you essentially get rid of the names of the variables and refer them to with their index. You have different options, underscore, .1, .2, .3.
I claim that you're not really any textually shorter than my version with X and Y.
Mm-hmm. Yeah. And if you have a name and arguments in the closure, if the variables are named, you have better options to give them more semantic meanings by naming such a variable.
Yeah. Now there's a this pointer on method style calls, which is a hidden extra argument, and I'm back and forth with some sort of dot notion for this, as opposed to underscore, but whatever. Yeah, totally the names. I'm like one-liner functions still, if I throw in X and Y, it doesn't make it any longer. And boy, a hell of a lot more readable, at least in my opinion.
Yeah, we use the underscore for the I don't care.
Yeah.
So I can say X, Y, underscore, which means, I have to take 3 parameters because I'm passing this to something that requires a function that has 3 parameters. But the third one I'm never going to look at.
I'm never going to look at the third one. Yeah. I could do that too. Actually, that's a good syntax. That's the don't care syntax. So here's your, I don't need Y, but I have to pass 3. So here's a function that ignores the Y argument. because it's
Yeah.
doing something with a rotation on a matrix, taking an X, Y, and a Z or something stupid.
And I don't mind
So-
that extra comma between those.
Yeah. Well, the commas I don't have right now, but I could totally make them. You know, there are people who love their commas here, and here's a version.
I love me some commas and curly braces and semicolons.
Right.
So one decision that I thought was terrible syntax the first time I saw it, but now I kind of like, in Clojure, the comma is white space. So you can use them to add clarity where you feel it adds clarity, and you can leave them off when you don't.
Comma is white space. That's interesting.
Yeah, I thought it was weird the first time I saw it, but then later it was like, oh, most of the time I don't need the commas, but sometimes things are confusing, and it's really nice to be able to add commas.
That's interesting. So here I threw an extra comma in because I can just drop it and don't care. Because if you have long lists of arguments, so you do them vertically, having a comma at the end because you need one between them, but the last guy in the line doesn't have a comma, it gets rid of that, makes it, you can have a comma and becomes
It
more
helps
refined.
with Git, actually. It helps with diffing because it doesn't show that line as being changed
For
when
stupid
you add
reason.
or
Yeah, exactly. The same thing for semicolon to me. A semicolon at the end is optional. You can have a semicolon.
So the question is, do we advocate for the Burgeon index
I do not.
anonymous?
I do not.
So,
I think the answer is it depends on the language because
Of course.
languages kind of hold together as a whole, right? So it's like, if there's a language that has that kind of theme going, then it makes sense in that language. Like awk,
Yeah.
for example, would be weird if it didn't have that.
$0, $1, $2.
Yeah, the fact that you don't have to name the columns in awk, I think was the right decision.
But your entire program has one set of column names. That's one of the differences with awk. The whole program ever only gets one set of names, which you just do $1, $2.
I never thought of them as names, but rather indices. Dollar is the name of the array you're accessing, and one is the index if you want to from that array.
Yeah, and
Look at
that's
these things as how they affect readability, and it's not just readability for you; it's readability for the person coming after you that needs to look at this and understand what's going on.
So in awk, I would assign
shortcut notation.
$1 to a variable that gives meaning to what we're looking at, and then use that variable afterward.
but only within that particular match, because that same column holds different values for different matches at different times.
Yep.
But yeah, it all makes sense.
And the question is like, how when you get into these really shortcut notations, you're really making a lot of assumptions that I'm not sure that downstream readers are actually going to understand. So I know I get the idea. It's maybe better for your velocity, but I think for downstream velocity, it's a loss.
Yeah, I like the way some people talk about it as a budget. Like, for example, there was this conversation a while back on some forum I was reading where they talked about it as a strangeness budget, right? Like, so if you're building a language, you get a certain budget to spend on, things that are different from what someone would be used to, right?
Oh yeah.
So, so you don't want to spend it all at once, right? So you want to choose to make something different only for, very specific reasons.
Yeah, I completely agree with that. I mean, I think, this is, that concept is one of the reasons that Java beat out Smalltalk initially, is because if you look at Smalltalk code, it was too strange compared to what people were being taught.
The curse of the C-style syntax, C-like syntax.
Well,
C-like
it's
syntax.
it was a procedural world, right? And still largely is. And there was a strangeness. I don't think we had the word strangeness budget for it, but there was definitely a differential in what people expected from what was there, and that just threw people off, right? So that they were looked at it and they just didn't really understand what was there, and therefore they just said, okay, I'm not seeing what I expect, so therefore this can't be good.
And just for completeness, I want to add, there is a programming language new like Unison, where for them it makes sense to anonymize the arguments for their indexes because they save the code in the database. So if you essentially when they compile the code, they compile a hash of the function, and that function has to be anonymized because if you call it with the different names, it will compute to a different hash, and that makes sense to anonymize the arguments and refer to their indexes, which is I believe the only valid reasons when you should make a function with anonymous arguments. Essentially, they save it in the database and refer to the function with their hash. And if they do not anonymize their arguments, when you define a different function, it will compute to a different hash. But if they're with the index referred to the arguments of the function with their indexes will compute to the same hash, and they can reuse that function.
But that just means that whatever's doing the hashing needs to have canonicalization. You don't need a language feature for that.
Yeah. But as one valid reason why do you want arguments to be referred to their index.
So to the conversation about too many differences or not, one of the things I think is maybe now becoming more popular is people passing short one-liner anonymous functions into other pieces of code. And that was different from the land of C, where it was really difficult to do that. You did macros or you put the function somewhere, but passing a function pointer always had horrible typing issues, or you void start it to get rid of the horrible typing. And now these days, I think people want to see the ability to pass small one-liner anonymous functions. However, that syntax is.
MapReduce,
Yeah, this is a MapReduce kind of style call, right? Whatever the hell I'm doing here.
Yeah, that style has been normalized though, right?
Yeah. But in the last 10 years or something. And when Java first came out, think back in the day, anonymous functions looked weird. Haskell had them forever and a day, been there, but that was kind of weird if you were not from the Haskell land.
Right.
So these days, I think one-liner anonymous functions are good, and you need a short syntax for them. Python's having it for a long time too now.
If you have a function, if you have a language that does very much functions with the one-liners, then it makes sense to make them anonymous, and that's a valid reason, I believe.
For your anonymous functions, can they call themselves using a this?
Like self-recursive, right now, if a function wants to be self-recursive, it has to be given a name. So I could come up with a syntax that did a self-recursive one, but if you nest self-recursive functions, at what layer does this pointer refer to? I guess it refers to just the innermost one. You have another syntax for talking to the outer versus inner layers.
You can take approach from the Scala. If you can name the this pointer, and if you nested functions have nested this pointers, you can name them differently, and that way you will know what you're referring to.
So here's a self-recursive function. I don't know if I got it right, but something like that just says it refers to itself. Now in my language, actually, all functions are always anonymous. However, it gets assigned to a variable called fact. The variable fact gets used, so I do the lookup on what fact holds, which is itself, and then you get the recursive function.
And it's not going to get mad at you that fact isn't defined yet.
No, I specifically allow forward references of function types because I'm just going to close the loop. You can do is odd, is even, mutual recursion the same kind of way. But otherwise, forward references are currently not allowed. We could argue that it's not what you want.
If I nest too deep, am I okay?
Yeah, should be fine. I guess I don't have an example to go test that, but I don't. The parser and the language setup shouldn't care. I have a couple. I get Fibonacci in here as a test for multiple calls to the guy I'll work, but I haven't got a test for 2 and 3 deep self-recursive calls. I could.
So as long as both functions get defined before either of them is called, mutual recursion is not going to get mad at you.
Yeah. If you define is odd in terms of it is even and is even in terms of is odd, and if you call is even before you've defined is odd, you'll get a blow up because is odd's not defined. But if you define them both, if you close the cycle, he'll take it and be done.
And if I never define one of the two, but I also never call them,
No,
it's dead code, who
never,
cares?
Yeah, dead things never get a type error. They just get thrown away. So you can have type errors on dead things. It's all good.
That seems elegant.
That's the theory in. C is odd. You go there, get my inversions and something like that.
What are you done there?
Did I get it correct? I have the code. It's a test
Do
case.
you
I was expecting a
compile-
bang in there somewhere.
It's like a what?
I was expecting a not in there somewhere, but
Um,
I guess it doesn't need to. It just walks down the thing saying, is it even and is it odd?
yeah, that's just the. Oh
Very
yeah,
very
I have
lispy.
a tighter definition here. This is the code from the test case here. It's morally equivalent without extra white space, so it's hard to read. Let me write it with the white space. It's a little easier to read. But it just does recursion down the line. I'm just going to add a little white space here.
You were talking about performance before. You expected out of this.
Yeah, no, this code will boil down to what you'd expect a C program to boil it down to.
Except when you apply it to 0.
It'll do what you would expect a C program to do when applied to 0.
It'll try -1, and that's not 1, so it'll try -2. And
Yes, I'm claiming that wasn't a good version of it, but it will emit code what you'd expect out of a C compiler. Here's the version my test case has, which just does the test up front. And for 0, it stops at 0. So if you put in a -1, of course, it's going to run down to a negative infinity. With any integer value above 0, will count down to 0 and stop and report. You know, this isn't meant to be performant code. Like you can write slow code in any language. This is just writing mutual recursion.
I wasn't serious, Cliff.
Yeah. Well, there is a
before.
question that the code involved can be boiled down to efficient code.
So the version that C compiler emits, you mean the one that formats your hard drive?
So Cliff, all we want to know is if you did a tail call optimization for this infinite loop.
Yes.
Mutual take calls of a function calling each other will be optimized in a one loop. While
They will turn. Yeah, I'm promising tail call optimization. I don't have it always. In this case, I do.
Yeah,
This case,
mutual tail call.
Yeah, I will take.
Oh.
I will inline until I have one function, and then I will claim it's tail called and turn it to a loop. But that's not tail call completely, but I'm going to do tail calls because people want to be able to write that style. And if you're a C guy, you won't ever write it, you won't ever care, and it won't matter to you. But if you're a functional guy, you'll write tail calls all the time and you'll care. So that the tail call is sort of like it's an unrelated thing.
Yeah, but Scala doesn't optimize the tail call, and for the for comprehension, it does optimize the tail call function, but the for comprehension, because you have a extra flat map at the end, you can optimize the all function in one loop. That's unfortunate. That's very unfortunate because you have to do some magic. You have to bounce from the heap, from the stack, and your function takes a 50x performance just because you cannot finish in tail position.
Yeah. Okay.
That's very
that's a different problem, though. That's
of the tail optimization.
Yeah. So here's a syntax question for you. I want a for loop that does something on exit if it found an answer, like find and do something, and otherwise do nothing because you didn't find, or do something else, right? So the sort of standard Boolean found equals, false, for I equals 0, I less than n, or while true, fine, I don't care. If predicate of array of I, I'm doing this in an array notion just to go with the theme from, Cameron here. And then I would say, Boolean equals found and break. Oops, break. And I need to have more parens, and I'm getting auto capitalization. And then if found ... So the issue here is simply I want to have an else clause or something like that. Or you put the if found piece inside the for loop that says if predicate, then I say, oh, do the thing I want to do, and then break
Scala
out.
has a magic to
Yeah, the
name
else
a value to bound. I believe Scala has a magic to bound the variable inside the for loop, and you do something with it.
And then there's an else at the end that says I didn't find it. Oh yes, okay, fine, never mind. Yes, I want the Python syntax for an else clause on a for loop. Fine.
But I would call it something other than else. I feel like I have had many students who got confused with Python's for else.
Oh.
And I'm like, oh, when you see a for with an else, read it as no break. For this, no break, do that. Oh, okay, now I get it.
Yeah. Okay, interesting.
So I agree with the syntax, but I would pick a different name than else.
Okay.
I
I
think
currently
Kotlin,
don't have a syntax for for loops or any loop at all. I have only standard user variables to do for loopy things, which makes my syntax weird, and I don't like it. So I haven't sorted
someone
it.
told me that Kotlin, basically all the statements can also be used as expressions. So you could imagine that for, just like, there's a switch expression now in Java, for example. In theory, you could have a for expression. So then you basically return a value out of the for, and then you put the for inside an if and do a standard if then else.
We will have to clarify what do you mean exactly by the for. So Scala for has a different meaning when you're inside the for comprehension. We'll have to agree on what for. If you have in Scala for comprehension on the list, then essentially it will do a flat map. Every call will essentially be a flat map.
Yeah, some people will want the reverse behavior, right? They want the for loop to find something and then act on that rather than act on nothing.
But yeah, you get up with both. Here I threw out a syntax which actually I am doing, but I don't necessarily like it yet, which does a do as a normal user variable that just defines how to do looping shit. It's just a for loop implementation at user level. Takes the two functions. The first one is your looping guard test. The second one is your body. If the body exits with a positive value, that's the value of the loop exit, which is your true case, and you get the found code. Else you fell off the end, so you're in the not found code. So this will give me my if then else, my for else behavior, although I'm not fond of the do loop syntax I have there.
I normally don't worry about this. I put the test of the loop termination inside, and if it's false, I do the not found part. Otherwise, I do the found part and break.
So if the found part is small, you do it and you break. And then when you fall off the bottom of the loop, how do you know that you didn't do or did do the found part? You have to have something that.
I'm talking about in cases where the not found part is the only thing you want to happen if you didn't find it. Right. Okay. So you say forever.
Yeah.
If not, or if we're at the end of the list, then do the not found thing and break. Otherwise, did I find it? No, keep going.
So you're not using a for loop.
Do what I want. Yeah, just a regular for loop.
No, regular for loop you don't get an end of loop. Write some C code here.
Yeah, all right. So I write like this.
So I'm claiming use a for. Okay. So Aaron, no, I'm sorry, I'm looking at Aaron's code. Yeah, Aaron has a default, which is what we're talking about. That's an interesting version there, Aaron. Although I would put the test in with the increment and the init just comes before. So I would have a test, a body, and a default. That's an interesting version. I didn't think about that one.
Why does init and increment Why is it just test body and defaults?
Well, because init and increment can happen before with just regular old stuffs. So the difference, but maybe you're right. So the difference here is that I don't have a way to have the variable I. In my example I wrote, I don't have a way to have the variable I span between two different function bodies unless it predates them in the scope. So then I get an init that's outside of the do. And the C style syntax was that for a long time. And then sometime, and I don't know when, 2000s, they added a version where the int I inside the for loop put a scope in the body part. So you had to have an init, but it was very useful. I mean, it makes it clear you just have this index variable just for the scope of the body. I don't have that without adding a new kind of syntax. And I'm fighting adding new syntax, but I'm probably going to do it in the end. Yeah, right. So what you did there, Keith, was that you put your exit test not in the for loop, but you put your exit test specifically in the body.
Yeah, and this is, you know, if you know the loop's going around at least once, so in a do while situation, well, you can do the
Okay.
you can just reverse the two statements in the body and carry on.
That's okay. I'll take that as an interesting approach. I hadn't thought of that one. I usually put the I less than n in the for loop, and then there's no test for the exit. And
I also missed the incrementing of I, but that's, you know.
We're all being friendly on that kind of syntax issue.
I feel like I've seen that style in a bunch of Erlang code.
So actually, this reminds me, I don't know if anybody else has heard of the Waterloo systems language.
I've heard of it.
Yeah. So one of my first few work terms going to the University of Waterloo, I worked at the computer systems group there, and that was the language of choice. It was, you know, so before we started working on C, and it had some interesting constructs that I've never seen anywhere else. And I tried to simulate them with macros in C, you know, didn't get too many takers, so it kind of.
Can you describe what is the structure? What is?
But the structure was a guess statement, and so it's, you know, imagine it had braces, if I remember correctly. Actually, that's not really relevant. So you know, the structure begins with a guess keyword, and you can label it in case you want to nest guess statements, and then you do some stuff, and you know, you sort of, it's intended for backtracking. So you can, you know, you work along a little bit, and if you discover some problem with the assumption you made at the beginning of the guess statement, you can say quit, and that gets you out of that guess statement. All right, and then there's, you know, a contraction of if then quit is just quiff, but the flow, when you quit, it goes to the next admit statement inside the guess, and there can be multiple admit statements. So you can assume everything's going to be hunky-dory. You work a little ways, and oh, you got a problem. So you quit this strategy and you move on to the next strategy. All right. And well, then maybe that works for a little while, and you have to resort to strategy.
Isn't this equivalent to a break statement in a for loop?
So
because
it's not a break in a for loop.
You can, so the macros were, you know, the guess keyword mapped to the beginning of an infinite for loop. Admit was a break statement, but I forget quite how we managed the multiple admit statements. And anyway, so, and then an end guess, you know, you have a loop that doesn't continue. Anyway, it was, like I say, very good for backtracking situations.
Yeah, I'm hearing.
Without having to have, you know, local variables to keep track of where you're at.
I have a coding style that often looks like top level function if, and if I got to the end and I got an answer, I set something else, there was a null involved, and then I'm back over. And if I have something, I'm done, else it's if, and it's sort of a series of strategies. The first one wins. And so, Cameron, your guy, you just put the loop for the find in a function, which I often do because it makes such cleaner code. And here's Aaron saying, I have a hidden induction variable underscore. Yes. So Aaron, I would just assume the 0 by default, but you could totally argue that, you know, it's going to be.
Well, I need to start at 10 and go to 0, maybe sometimes. So.
Well,
Yeah.
no. There's a 0 to an exit value to a limit, and then there's -1 or some weird starting point to something, and there's count by minuses and everything else. So there's a version that you want to have that's the default that 90% of people use, which is I went from 0 to a limit. Like this would be a syntax where body would have available the underscore for me, but of using where I just defined underscore as a local variable that was good in the following functions that had a scope. This requires the for guy to have a scope thing.
Yeah.
Right now, my for loop is standard user code. It doesn't introduce a scope. It just takes 2 functions.
Yeah, it's got to be a kind of weird macro because default has to run in the scope of body, which has to run in the scope of test, which has to run in the scope of increment, which has to run in the scope of init.
Right. The actual thing I do here is this do pred and body. I force another layer of scoping. Right. So that's a little uglier because I force another layer of scoping in order to get I to span the both predicate and body, and that I don't like that. So I'll probably have to hack on this at some point. For loops in C actually introduce another layer of scoping for the index variable, and I probably will have to do that too.
You're referring to when the index variable is named. You do a for I, but I saw it in the code. You name the I with the int and then it's bound in the scope of the for loop.
Like a standard C code has the int I has a scope for I that's just in the body, and it is not alive after the for loop.
Yeah.
So you can repeat for loops for int I, and the i's don't collide, and that's important.
Oh, yeah. Cool. Mm-hmm.
Yeah, I would argue if you mutate the I in the body, when you start the loop again, increment should get its own I and just sort of get rid of anything that happened in the body.
Well, right. So if I do two back-to-back for loops, not nested, I'm sorry, 2 back-to-back for loops, the i's are utterly different and the body can do whatever the hell it wants. Right. So let me do here, you know, I is equal to whatever the flock you get out of the first guy, right? Like occasionally I do things where I have work lists and I spin down the array and I pull an element out by shrinking the array, taking the last element, throwing over the one I threw out, and then I want to decrement I so I can re-increment it in the plus, which I didn't show the plus here. So, but I is not monotonic. So I've hacked I. When the next for loop comes around, it's a different I, utterly different, completely different I. So those scopes don't overlap.
So if my incrementer is I++, and in the body of the function I have I minus, do I have an infinite loop?
If that's all you got in C code, yeah, you can do that.
Yeah, I get that in C code that's an infinite loop.
It's syntactic sugar, literally syntactic sugar. So you just unwind the for loop as syntactic sugar, and you have an I++ and an I minus, and an I less than 10. Well, it goes to 1, goes to 0, goes to 1, goes to 0, never 10. So boom, infinite loop. Yeah, it's just syntactic sugar.
And you think that's better than having every iteration of the for loop essentially be its own scope?
The problem with having every iteration be its own scope is that you can't carry knowledge between one iteration to the next. Which, for instance, if I'm throwing something out of a work list, I'm finding an element.
Unless you initialize those variables in the init phase and said, by initializing this in the init phase, I've declared this is a variable that I want to survive the scope of an iteration.
Okay, so the for loop as defined in C code, the init phase is just for the body. That's int I equals 0. If I want to have an I survive, I put it outside the for loop, which I'll just write this here, and I++, and I won't put the less than 10, but there's a body, and life goes on. Okay, so here I've said I is outside, I go through the body. If I exit the body early, for instance, I is less than the limit value. I know something about I, and it's useful, and that's one of the ways I do these for loops with finds. If I exit early, I is less than the length of the loop. That's my hint that I found somebody. And the I is pointing to the first guy I found.
What would be the benefit of every iteration being its own scope?
Well, that's the for each syntax. You don't need an iterator.
The advantage is that the compiler can tell whether you intend to carry a certain state from one iteration to the next iteration, and it might be able to pull tricks with what is dead when.
That's maybe essentially like a tail call optimization, that you return only one value at the end. You don't carry any state at the end of the function. You call again.
As soon as
And-
you have no state, you nothing to return. So you're in it for the side effects.
Yeah. In a regular tail call optimization, the last thing you do is to call the function again, and that can be optimized as a while loop. Yes.
Yeah.
So would you
I-
say that the for loop should have, that I should be able to pass an argument into break and say, when I break this for loop, here's the thing that I would like to return
That's
to
what I
whatever the result of the for loop is being set to.
Yeah, of course, they have to have a condition to return something upon
Give break,
termination.
an expression. You say break 7 if that's
Yeah.
the answer you want.
That is how I am doing for loops right now. The body can return a value, and if it returns a non-zero value, that's the value of the for loop. That's the same as a break.
So if the body can return a value, the break needs to be able to return a value also.
That the body is, for me, the body is a function, standard function. It just returns. So it returns what it returns. So you write a function, you can return a 7, but just the return keyword, which
Doesn't the
so break is
just,
return.
yes.
Mm,
For me, break
Yeah.
is return. I don't have a break statement. I have a return
Yeah.
of a function. That is the break.
I perceive the break is that break out and break to the enclosing scope.
Yes.
I perceive that.
I understand that. And what I did here was I said all my scopes are functions, anonymous functions, and you just do a return. That's the same as a break.
What's your structure for a non-local return? You want to return out of the 7th layer out.
I don't currently have such a thing. I will probably have to come up with
the same kind of notion, right? A block returns a value, but a block could return from the lexical scope.
In C and Java, you can have nested for loops with nested bodies that are complicated, and you can use the return keyword to exit the function, which pops all scopes.
Right.
Yeah.
So I'm
right now.
How do you do that in your language?
I could. I don't have the syntax. The syntax would be obvious. It would be 2 hats instead of 1 hat. That would be the standard return. Early return is a hat. So
You're going to confuse small talk people though, that
I
understand
don't have a
the non-local return.
So, an anonymous function, it returns the hat is return 1. So predicate's true, return 1, else do stuff and return whatever stuff returns. In this case, it's trivial. I don't need that hat because I'm just got a question mark colon, but that's the, so non-local return would be pop scopes until you exit it out of other than a for loops style function. So all my scopes are in functions, just period. I have no scope creation that doesn't involve a function. Structs have a scope too, damn it. Yeah, okay, I have to think on this one. Structs make a scope too. But that gets into zone where, like small talk, and so it gets a little weird. I write code in it, it looks interesting. It's not what you expect.
This may be a strange question, but you are in a garbage collected language, right?
No.
Oh,
It
you
could
are
be.
not.
I am in
Because-
an optionally garbage collected language.
I was about to ask whether you need to pop the scopes, because in C++ you need to pop the scopes to run the destructors, but if you have garbage collection anyway, then you might just drop all of the scopes.
Wait. Those are very different things.
Yep.
Destructors have lexical behavior, which is important. And I really like them. I've used them many years. They're great.
Oh, so you keep the, okay, you keep the
Yeah,
destructors.
GC does not have lexical destruction notions, but is
Exactly.
very convenient if you don't want to track lifetimes. But some people do. So my current theory is I'm going to get Rust style memory management thrown into my lattice and track lifetimes, but I'll have an escape hatch which says, and now I'm going to GC. And if your program never GCs, you don't need a GC installed in it. You can write, fucking device drivers and shit. But
Okay,
if you
so
want a GC, you can have it.
This reminds me of the conversation you had with Cantrell on that panel.
Oh, maybe.
He was complaining that he
There are
wanted to
some
be able to have
advantages.
scopes.
There are some advantages to purely garbage collected languages. Like the common problem in C++ is tree-based data structures and destructing them. So if you have a tree which has a node, and that node points to a node, which points to a node, which points to a node, if you distract them with something like reference counting, you have to unwind them one by one. But in garbage collection, you can just blow the entire tree in one cycle. So
and I'll hand you the flip, which is I can write a Java program that says for I equals start of file to end of file, read a line, process a line, and it's a gigabytes to terabytes file. And if I take the default behavior from Java of making a new string to copy every line out into a string, and then I string split and do my string math and whatever, it's 10 times slower. And I can show you the code that did you just run it yourself? Yeah, 5 times slower than doing a one object pool where I recycle the string line by line by line. So it's hugely slower to rely on the default GC behavior in cases where in a C program, I would do malloc and free line by line. And of course, it would just, the malloc and free would just hand me the same code back, same virtual memory space back over and over and over again, which lands in my iCache, my L1 cache, or my L1 cache every time. And that's the giant speed up. So,
and I see that mistake in production every single day.
Yes, I do too. This is why I teach it. That's one of my classes I teach. And
doesn't defer keyword be more appropriate for this? Defer? What about a defer keyword to when you exit the scope and you deallocate all of it?
There's a thing where it says I want to have some kind of help from the compiler to verify that I am not doing a new allocation for every iteration of this loop, because that's where my cost goes. Sometimes I want new allocations, but mostly I don't. And if I'm doing it every line, I'm probably losing. I'm losing by integer factor speedups. So that's a performance hit that I want to have a way to let somebody not fall into that trap. So I don't want an only garbage collected language because it's hard to work around it. It can be done. I do it in Java all the time. It can be done. It's hard. You have to think about it. If I give you a Rust style allocator and garbage collection, then there's a deal that says, when I care, I'll put a little effort into the Rust style and I won't be allocating in this loop ever, other than, the coming and going in every iteration. And if I don't care, I just throw it at the garbage collector and forget about it, move on.
Yeah, that would be ideal. Yeah.
I have way too many goals that I have, time and energy. But I think that's one's doable. I think the Rust style stuff falls into my normal lattice theory fine. And then there's a pile of implementation that goes with it. Whereas GC, of course, is a giant wad of hard problem that's well understood, but it's a giant wad of a hard problem to actually go make one. The other thing I guess I fall into the camp is like the Scala escaping to this pointer. That's the same kind of deal. As soon as I escaped to this, I had to throw it in the heap. And I don't want to throw it in the heap. I want to have it stack allocated. So same kind of problem. I want to reuse it continuously and not GC it.
It would be cool to have some kind of GC to code to define a region that would be GC and just throw objects in there.
Yeah, the default, there'll be lexical scoping, but the default will be everyone's GC'd until you say don't. And here I care. And then then I'll complain if it would appear.
Also, one thing to consider is not making your allocator effectively a global variable, which most languages do. If you have a language which has a new keyword and you can access this new keyword from every scope, and then congratulations, you have introduced a big global singleton allocator, which is now tied with the entire application graph.
Yeah.
I think getting rid of that may be a good idea, especially if you want to have regions of memory or localized per-thread object pools, for example.
Some sort of lifetime management besides just doing new. Yeah. All right. We're at 12:08. So this has been a good Coffee Compiler Club. Let's do it again next week, but I want to go get lunch.
Yep. Good. Cool. Okay. Till next time.
Till we meet again.
Bye. Oh, cool.